listen to the silence of space. Tonight, we will fall asleep to stories about the space station and those who work there. Just close your eyes and let the voices from NASA take you to the stars.
Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, episode 21, Microgravity University. I'm Gary Jordan, and I'll be your host today. So this is the podcast where we bring in the experts, NASA scientists, engineers, astronauts, sometimes educators, all to let you know all the coolest information about what's going on in space. So today we're talking about the way students and educators are involved at NASA with Mike McGlone. He's an education specialist here at the Johnson Space Center in Houston, Texas. And we had a great discussion about the different programs here and how they influence students to pursue careers in STEM and STEAM fields, including careers here at America's Space Agency. So with no further delay, let's go light speed and jump right ahead to our talk with Mr. Mike McGlone. Enjoy.
T-minus 5 seconds and counting. Mark. All launch commit lights are correct. There she goes.
Houston, we have a podcast.
Okay. Well, there's some, is Microgravity University, so I was doing some research, just to understand kind of the whole thing. Microgravity University is the parent brand, sort of, that kind of overarches, and MicroGenex is one of those things, right?
That's right. Microgravity University is an overarching, it's just an umbrella, it's not really an organization, but it actually started several years ago with called RGO's Reduced Gravity Opportunities. It was where teachers and educators and even students designed experiments to then come and fly on the C9 aircraft, the Vomit Comet, and do those kinds of tests. But as that program phased out, they looked at other opportunities, and that's what we've looked at, like MicroGenex with the MBL, and now Microgravity University for Educators, which our current activity is then focused over on the Precision Air Bearing Floor, the PABF, over in Building 9, the Space Vehicle Mock-Up Facility.
Okay. So what's special about that facility then that lets you do the challenges, I guess?
Well, the Precision Air Bearing Floor, if you think about it, is, if you've been over there, it's a large steel plate, it looks like.
Okay.
Polished, highly flattened to within, I don't know how many micrometers flat it is for the distance it is. But it basically works like a reverse air hockey table, if you ever played on one of those at an arcade or something. But instead of air blowing up to the floor, whatever item you have sits on pads that the air is then blown down to lift it up and give it a near frictionless kind of surface. So that allows us to do microgravity in 2 dimensions.
Oh, okay. Very cool. Well, so what, I'm trying to imagine what kind of microgravity you can do in a 2-dimensional environment. What's a challenge that you can do?
Well, the challenge that we've come up with, we used last year and we're using it again this year, is we're doing a simulation that's very similar to, well, one thing that we do on the International Space Station where we're launching small CubeSats into orbit around Earth. Mm-hmm. We're taking it a little bit differently in that we're looking at a moving satellite trying to launch a small satellite into orbit around Mars. It's an orbital insertion. So if you can imagine a moving object that's held your satellite, moving away from a target that's moving almost left to right in front of you and firing an object to hit a target. Very challenging.
Yeah. So it's kind of like target practice, I guess, but in 2 dimensions and in microgravity kind of thing?
Right. And other than, standing still and hitting a target, you're moving as well. So you've got 3 different motions actually going on.
Wow. And it's really to simulate real orbital insertions?
Yes,
Is that kind of
yes, very similar.
Okay, very cool.
And adding in the robotics to it because it's supposed to be autonomous. Once they say go, turn on the air, everything begins to move, then it has to respond on its own. So there's robotics involved with it as well.
All right, let's pull back just a little bit because microgravity, we're kind of getting into the, already some of the challenges, but
right.
I kind of want to get like a full understanding of Microgravity University, just what it is and who does it, who participates, that kind of thing. So what's like the overarching, description of Microgravity University.
Okay. Well, Microgravity University for Educators, MAGOO, and I'll try to refer to it as that.
All right.
Is it's an opportunity. Well, actually, let me back up. It's in the second year. Last year was our inaugural year. We've only made a few changes to it this year. I'll talk about those. But it is an opportunity for educators and now students involved this year to bring this device to meet this challenge I just talked about, to design and build that back home, and then send a visiting team here to Johnson Space Center to test it there on the PABF. So that design challenge really brings in all across all the components of STEM, science, technology, engineering, and mathematics that we're really trying to reach out and engage students with.
Yeah.
And give them an opportunity to bring all that to bear on a very challenging, authentic learning experience, and then bring a team here to actually test it in our unique facility. So it's a bigger team back home than gets to come, but it's we're inviting actually 2 educators and 4 students, high school age students, to actually come here and do the testing.
And it's the educators from that school, I'm assuming?
Educators from that school. We're using the term educator as opposed to teacher because it's open to, it could be a school district. It could be tied in with an informal education as well. So it could be with a science museum or like a 4-H or a scouting unit, because those are education programs that have STEM outreach as well. So opportunity for them to take that on. So.
All right, cool. So what kinds of what was last year like? How was the setup? Who came and then who participated? What was the challenge?
Challenge was very similar to what we're doing again this year. What was different was that the teams that came were only educators. Teams of 5 educators came. We had them from across the country. I believe, if I remember correctly, we had 9 states represented. No, that's not correct. 12 states were represented, including Puerto Rico.
All right.
And those were working, we had a variety of teams. Some that were working with one school or one program. We had some that were working across the school district. And we even had one team that was made up of the 5 teachers came from 5 different schools from across the country, from California to New York. Yeah, that was an interesting challenge for them. Not only what they were doing for us on the engineering, but just their learning how to collaborate together was a big challenge for them. We had a local team here from Clear Lake ISD as well, so it was quite a diverse group.
Yeah, definitely, all across the board. So then, the whole thing was, once you got, I guess, you put forward a proposal or something, right, to participate. Is that kind of how it starts? Right,
that's how it starts. We send out information about the challenge and the technical requirements. There's a lot of safety they have to cover to be able to come work in Building 9, the space vehicle mock-up facility, and work on the PABF. So we send out all that information and invite teams. Like I said, schools, school districts, informal groups, or some combination thereof, to send in a proposal. And then we review those. We review them both from a technical standpoint. Some of our support folks in Building 9 will read it from a technical standpoint, and then we'll also read it on the education side, because it is an education event and outreach and a number of things. So we read it from the educator point of view. Yeah. And our top 10 teams will get the invitation to come down and participate.
Oh, okay. So anyone writes the proposal, anyone kind of puts this together, and then it's up to you to decide who's going to come down here for the competition.
That's right. It's a nationwide competitive proposal process. We read them, we do we give them the rubric so they know what we're expecting and what we're looking for, all those criteria. And then, we do the reading. We always make sure there's 2 people that read it in each section just to make it fair. And then they just get simply ranked, and the top 10 will get the invite.
All right. So then once they come here, what's that whole setup? Now you got to narrow down to like the best of the best teams. So once they come here, what's that week look like?
Well, that week is very, very fun and very, very busy, as you can imagine. They will come in. We'll give them a chance. We've got to get them oriented, of course, to Johnson Space Center and the environment here. So they'll get a safety briefing. They'll have to go through, and even though we've read about it, now everybody's actually can get hands-on and look at it. So they'll go through a quick safety review. We'll make sure it can work on the precision air-bearing floor. And then we'll get a chance to test those. We'll give them a chance to go back and maybe make some adjustments and come back and test it again over the week. That's the gist of why we want them to be here, is to actually go through that process.
To test it out for like the real thing, right?
Right. Give it a real test. Not in a competitive nature from one to another, but for themselves, just trying to be successful going through that engineering process. But the other things we'll do throughout the week, we'll give them tours of the overall JSC facility.
Oh.
We'll want to give them some unique experiences. I'm not sure what we're going to do this year, but last year we gave the teachers an opportunity to do a simulation in Building 16 on one of the docking simulators. They got to ride on the Mars exploration vehicle. They also got an opportunity to get on the partial gravity simulator, or POGO, over in Building 9, which is the old pneumatic. They put you in a harness and take the load off so you feel like you're on a spacewalk.
Wow.
So they did a lot of things I've never had a chance to do myself. It was a wonderful week. I had fun just watching them.
Yeah. Sounds like the microgravity part of Microgravity University you're taking to the fullest extent, right? Really putting them in a situation where they're experiencing it, where whatever they're designing is experiencing this microgravity and simulating it, right?
Exactly.
Yeah.
And even beyond that, using it back in their classroom, teaching about microgravity and that environment. And that brings in so many things for teachers as far as, Newton's laws and force and motion and energy and all those things they have to teach. But thinking about it from a standpoint that they often don't think about in the classroom is from that microgravity environment.
That's true, because maybe they don't, even without studying it, it's kind of hard to grasp, right? The idea that, you just know that everything goes down. You just know that you have, apples fall on your head. And when I'm sitting in this chair, the chair is going to stay on the ground, right? It's not going to float up and go towards the ceiling. But there's this whole different mindset when it comes to microgravity and how that applies to the International Space Station.
It really is. And it really has to put them in that mindset. Like you said, in our day-to-day situation, we don't deal with that. Here on center, we may even talk to astronauts and watch all the videos that come down from the ISS, but until you actually work and have to work in that environment where the friction, the things that we deal with kind of unmask that real microgravity environment, is hard to do. You may know what happens, but until you actually start trying to make something work in one of those simulated environments, or I'm sure on board as well, it's a real challenge.
Oh yeah, and it kind of as part of this whole experience when they're here. Actually, is part of the experience kind of studying what the astronauts are doing on the International Space Station as part of Microgravity University? Are you connecting with them or studying videos or doing anything that sort of emulates what you can find on station?
Well, not directly with this particular experiment or experience. Pardon me. In a way, it is very similar to what the astronauts are experiencing, because they're on board working through. They're the person up there that is actually operating a lot of the experiments that are on board, or doing the experiments. Oftentimes, they're the experiment themselves. With a lot of the human physiology that goes on. So, in essence, that's kind of what our visiting team is, and we do try to make this parallel. Is they're representing this whole team that is back at their school or district or their organization. So they have this team that is coming here to do this test and make what adjustments. And I probably should have mentioned this beforehand, but they really are going to continue that communication throughout. So if they, when they go through their first rounds of tests and maybe they find that it doesn't quite work the way they thought it was, we want to give them a chance to fix it, but not just the team here. We want them communicating with the team back home to actually make some of those adjustments. And that was something last year that the teachers found. It's going to be interesting this year with the students involved, how this is going to work out. But with the teachers last year, it was fun to watch them communicating with their classes back home. Because sometimes it was the student was the only one that knew how to really program it, of how it was going. It wasn't the teacher. So they were having to tell them to change this parameter or this setting, and then download it to their device and then do it. It was some interesting FaceTime conversations that I overheard and watched them doing, and holding up their camera, showing the device as it went, and hearing all these students, you should do this, no, you should do this, now let's talk about it, because they're trying to do it very quickly. So sometimes it seemed like chaos, but it really worked. it really worked out well, and was very exciting to watch how engaged those students were, because we were also live streaming it back to them as well, so they could watch through Ustream an overhead view of each one of those tests.
Whoa, okay, there's a lot more going on.
Oh, there's tons of it's hard to even think of all the layers that are going on with this as well.
Yeah, I'm trying to get a full picture. So now you have, what's the setup of this giant air hockey table? Is it just like a big square? Is that kind of how
It's a large rectangle.
Okay, all right.
Probably the size, I wish I could remember the dimensions off the top of my head. It is, I'd say it's roughly 20 by 40 feet, roughly. Okay.
So definitely rectangular. And then all of the teams are around it, or are they?
We're there's only really room to bring one team up at a time with the operators, the folks in Building 9 that actually operate it.
Okay.
The other teams are sitting on the floor, though. They're at Building 9, just off there. But we're actually using that video stream so they can watch it on a TV. It's just down below. They're not too far away, but there's just not enough room because it's elevated. It's about 4 feet up off the main floor. So the catwalk along there's really room for one team at a time. So, we really wish we had a large gallery and could get lots of folks up there, but it's rather hard to do. So.
I see. Yeah, and then so on the floor they have their phones out or something and are Skyping or FaceTiming real time.
Exactly.
Like their mission control, I guess.
A phone or an iPad, or I had them sitting there holding up whole laptops, trying to get the right angle to get it on their camera as well. So. Yeah, it was fun to watch the different approach each team took to keeping up with that connection. And last year, one thing we were able to do, unfortunately, we won't this year because this resource is not, unfortunately, no longer available to us. But once they completed their test, they got a chance to do a direct video conferencing link with their teachers and students back home afterwards. And I know a number of the schools had whole assemblies during that hour of testing that they had at least on day one. Then they were able to go back and answer questions about how it felt to be there, about the whole environment, and that was really a fun thing to add last year.
Yeah, to add that, I guess, get a larger audience to really kind of experience it.
It was, and we hope that same thing will happen this year, but without that direct video conferencing resource we have, we're really relying on the teams to make that up with their own. They were doing it somewhat last year. We've asked them this year just to make it more part of their plan and to plan on that kind of connection.
Yeah, really, because it's almost like planning for just an operation, like a real mission here in Mission Control too. Because you got the folks on the ground, right? Quote, the ground supporting the astronauts up in space, kind of like that, right? You got your mission team up here doing this microgravity team, but then you got folks back home helping you out. Exactly.
It is exactly like that setup we have here between Mission Control and the folks on the station. And really, it took some of them between their day one of testing to their day two to actually figure some of that out after their test. We didn't lay it all out in front of them. It's a learning experience. So a lot of them made that connection second time around, and you saw changes like kind of randomly changing this. They came down all of a sudden. Then you saw them working with checklists and all these other things that we kind of expect to have in a mission. But so they learned on the fly, which was great.
Yeah, that's exactly right. So it sounds like a lot of it is obviously it's planned ahead of time, right? How long until you start the planning for the mission until the mission actually happens? Like how long is that stretch of time for Microgravity University, or maybe application to mission?
Well, the applications have been out. They'll be due December 13th for that next go round.
All right.
Give us, of course, with the holidays, a couple weeks to read them and evaluate them. We hope to have everybody lined up with their acceptance letters by mid-January, about the 15th. So from there until March 15th, they have about 2 months is all to design and to finish building this. Now, they've got a proposal already.
Sure.
Of course, everybody knows that from paper to actually building, there's always changes.
Yeah.
But so they have ideas in mind, but they've really got 8 weeks probably to just finish designing, build it, and send it down here to us, and be prepared for all this. So it turns around pretty quickly. The end of each team then gets a chance to come for 1 week. We actually have 2 test weeks, so 5 teams each of those weeks of the 10 that are invited. And so, yeah, it's a very fast turnaround. And then even there's follow-up because we expect them to go back, pull everything they did, their notes, their any data that they took, to pull that all together into a summary report, which then they'll share back with us as well. They'll do that remotely after the experience.
All right, so it's going to be pretty quick after the holidays here.
It is.
2018 is going to be rapid, like a really quick start to the year.
It is. It's coming very quickly, and getting all that stuff set up, working with Building 9 and getting the word out. Yeah, it's a very busy time for me right now.
Yeah, for sure. All right, well, we're going to put this out before that December 13th date for sure, so maybe you'll get a couple extra applications, which
We're looking forward to it.
I'm hoping you're happy. Otherwise, sitting and reading over the holidays all these proposals, I hope I'm not putting too much work on you. But where's the website they can go to submit the proposal?
The website is a very simple one to go to. It is go.nasa.gov/NASA Magoo. That's NASAMGUE.
All right, Magoo is Microgravity University, but just condensed.
Condensed, yeah.
All right, Magoo. Or you can just you could probably just search Microgravity University, right?
Microgravity University for educators will take you straight to ours. You do want to add that for educators, because if not, you'll wind up at that overarching. But you can find it from there as well.
Okay.
We want to make it as easy as possible.
Oh yeah, definitely. Wow. All right. Well, it's going to be a fun time for them. So, okay, we talked about the challenge itself, and we did kind of allude to some of the stuff they're going to see. I kind of want to go back there, because some of the things I'm kind of jealous. I feel like I haven't even done some of these things that the students are going to do. So, the first one was the simulator, right? What was that one?
They worked in with Building 16, one of the engineering simulators there last year. I believe the one, because I didn't get to go do it either, so I'm jealous as well. But they got to do, I believe, one of the docking simulators.
As if you were like driving it, or as if like you were trying to capture a cargo vehicle?
I believe this was trying to capture a cargo vehicle over there. And I don't know if you've been in Building 16, where they have the dome projection of it's kind of a VR setting to a degree.
Okay.
Not with the goggles, but just trying to put you in that environment. You're at a station that looks like on board, and then they surround you with a dome with projection.
Oh, yeah. We actually just talked about that last week on last week's episode with Shane Kimbrough. We were talking about that very simulator, because that's the same simulator that he used to practice robotic arm operations.
Exactly.
So it was that. That's what it was.
These facilities are doing the same ones that our astronauts train in.
There you go. How about that? It's pretty cool from what they describe. Again, it's on the bucket list for me here. I still haven't done it, but it's literally a projection of the Earth. So it looks like whenever you're training, you're inside the cupola. You're inside the same module on the International Space Station with relatively the same view that they have. Obviously, Shane Kimbrough said it was not the real thing, but it's pretty close.
It is pretty close from what I've seen. I haven't seen it recently, but yeah, it's a very nice simulation.
Yeah, and then you practice doing the robotic arms things, and they get no training, right? Do they actually go in and drive it? Do they actually run the simulation, or
Yes.
do they just watch it?
No, they actually go in and get
cool.
a chance to, not for a long amount of time. They usually go, their whole team of 5 or 6, so they each take a quick turn on doing it. Mm-hmm. So but they each get that hands-on opportunity.
Yeah. Wow. All right. Again, super jealous.
I agree. Like I said, I didn't get a chance to do those either.
Okay, so what's some of the other cool stuff they're going to see?
Well, definitely when they come down here, we want to give them a chance to see Mission Control.
Oh, yeah.
Building 9, of course, they're always working there. I mean, I think it's one of the highlights if you go on the tour from Space Center Houston or anywhere. It's always on the tour, but there's a whole lot of difference from being up on the catwalk where the visitors are and being actually on the floor working for 2 or 3 days.
Yeah.
As I mentioned, they also get to do Pogo there, the partial gravity simulator.
That's
or at least
right.
is one that we've done in the past. The robotics group, which is also there, has been great to work with. Mm-hmm. As I said, last year they gave the participants an opportunity to take a ride. They didn't get to drive, but it's still a fun ride in the Mars exploration vehicle. The little car that was a joint project with, I believe, GM. That can drive sideways or sit and spin in one spot.
Oh yeah, the MRV.
Yeah, the MRV.
Yeah, the MRV. That's a fun one, because it literally omnidirectional driving, so it can spin and go sideways, and that's a cool car.
They give everybody a chance to ride in that. Perhaps we'll do that again, or get a chance at one of the SUVs that are over there.
Yeah.
Don't know. Again, we're still in that. A few things we've still got to nail down between now and March, but there's definitely so many neat things to do here. We'll give them a chance to see the Saturn V over in the Saturn V building. which is always impressive, because we find most of the folks that are coming have never been here before. So
Yeah.
I said last year we did have a team from the local Clear Creek School District, but other than that, everybody was really their first time to Johnson Space Center. So
Yeah, maybe
it's amazing.
We might take that a little bit for granted because we go into work every day and pass literally one of the largest rockets, if not the largest rocket. I'm gonna have to double check on that, but that was the rocket that took us to the moon. So just laying on its side, just as we're driving by, and it's so cool it's like a hike to walk from one end to the other and see the whole thing. But it's definitely one of the cool things to see. Mission control, definitely pogo. That's a good one too, because you're kind of suspended on a string that sort of simulates, right? You simulates.
It does. It uses pneumatics and takes the load off so that you're suspended and actually feeling what it's like to be on a spacewalk. And they set up a nice little simulation to use handholds and move through 2 or 3 places and do try to make a connection of a cable into a socket, which, again, if you're not used to that, when we're sitting here somewhere, that's just grab it and put it in there. Well, you're pushing against the floor and all these other things that aren't moving. Well, all of a sudden, everything's moving. You take the tiniest push on that, and you're going the other direction all of a sudden.
That's right. Microgravity.
Microgravity at work. If you're not used to it, it's different, which I'm sure you visited with some of the astronauts. They'll always tell you that. But so this gives us folks down on Earth a little peek into what that's like.
That's pretty cool. Yeah, no, that's true. That's you're talking about taking it back into the classroom. Newton's law of anything in motion will stay in motion unless acted upon by another force.
Or that action and reaction. That's the one that really gets you on that spacewalk. A little push here, and all of a sudden you're on the other side of the room if you're not careful. So.
That's true. Talking with different, astronauts obviously, but then extravehicular activity specialists too. The trick is the slower the better. Right, because if you move too fast, then it's exactly that. You're already in motion. Now you have to stop.
Right.
So, understanding that whole thing, and now you got this 300-pound spacesuit that, even in microgravity doesn't weigh that much, but it's still mass that you got to carry with you whenever you're moving. So
you got to carry with you. You got to stop it. You got to start it. Yeah, mass is still mass, no matter where you're at.
Exactly. And does that kind of translate into the challenge too? Is there a understanding mass and how it interacts with this whole setup here? And
it really does, because momentum, you get into force of motion, you've got all these other things, momentum and energy that go into it as well. And that's one thing that they do get a chance to work with. Of course, the whole device has some mass to it, but since they're, if you think about an old physics class about talking about momentum, maybe shooting a cannon, and the bigger cannon will shoot the same size ball further, just because of the mass differences. They do get a chance to adjust some of the masses on the launching device that their sled is connected to, so they have to take that into account. Like you mentioned earlier, there's a lot of different facets to this that they really think through, and that's also why we focused at high school level for them to take it. Those that may have had the physics or a technology class that at least have been exposed to this at a little higher level. Definitely. Doesn't mean middle school can't be involved, but it's there's some pretty good science and engineering in here.
So that I kind of want to explore those layers a little bit more, actually, because I feel like what are they designing? What are they bringing to the table? And then what are the things that are here that they have to interact with? Like, what's the whole challenge then?
Well, the device that they're bringing, we provide them with, and this is similar to a number of design challenges that are out there in different places, is we provide them with a kit of some basic, simple materials. That is from cardboard to some dowel rods, some small pieces of wood, springs, rubber bands, bungee cords, things that'll give you the basics of a device, because in essence you're putting together this launching device. We call it the Satellite Launching Experimental Device, or SLED.
Oh, so you're building the launching device.
That's what they're building, is that device that's actually going to shoot a satellite. In this case, we use one of those little air hockey balls you might bounce around the kitchen. Yeah, the disc that's about 6 inches across. It blows air down, and you can bat it around. Yeah. That's the satellite that they're trying to launch from their device into the target. That's actually our satellite in this.
The satellite is the hockey disc.
Is the hockey disc.
Okay, cool.
So it's going to move very easily across that highly polished steel floor of the PABF. So they're building a device that's going to launch that, trying to hit this small insertion target that's moving.
Oh, the insertion target is moving?
Yeah, it's a moving item hitting a moving target. That's why it's there's a lot to this.
Yeah. Wow. Okay.
So they've got to decide, how to launch this, how fast it needs to go, which depends on, how much energy they need to put in this. Do they want to use rubber bands or springs or something more heavy duty?
Mm-hmm.
They do get a chance to enhance that kit that we give them with some things they have there as well, about 20%. It's an 80-20 rough guideline for them to use what we've provided and then design from their own materials that they have.
Mm-hmm.
And to me, the hardest part for them is to decide how to make that autonomous. Decide what mechanism they're going to use to release it at the right time, at the right speed to hit that target. Last year we had some that built their own breadboards. We had some that used the Lego Mindstorm robot to actually launch it, something they already had at their school.
Yeah.
And there are other options that other teams out there will find and make use of. Which is one of the funnest parts for me, is seeing the different designs that these teams come up with.
Yeah, a bunch of different designs for exactly the same task.
Exactly.
But, may the best design win, I guess.
Exactly. And once you actually, if you've ever been in one of these, it's not just the design, it's executing that design. So it's also building it so that it will withstand that launch and etc. So you've got to put some durability into it as well.
Kind of hard with cardboard and rubber bands.
It is, but they find ways. We had a team last year that took the cardboard box we sent them, which we didn't really have in mind at the time for them to use, but they used it as their basis and fiberglassed it.
Oh, all right. There you go. Way more structurally sound.
Exactly. So, using that, using their own creativity is really key to this.
Yeah, definitely. Wow. So they're here for a whole week then, and this challenge is it? You said there's a lot of testing involved in the beginning, right? You're kind of practicing and.
There is. It's over a week. So they come in on a Monday.
Yeah.
They get a chance that first day once they go through the safety review to spend an hour testing it on the floor, which depending on how well it performs or what kind of adjustments they make, they can get one shot into 20 or 30, depending, how well it works. We've got to work in that time for their experiences as well. Tours, the things that we will do.
Yeah.
And then a chance to do any modifications they need. And then they'll also get a chance then, and that's probably what Wednesday is. Then on Thursday, they'll get a chance to work through it again and see if the modifications they've made work better. And they'll have about another hour on the floor to get as many shots in as they can and see what successes they have. Because that's what you're looking for, is not that they can do it once, but that you can do it repeatedly and fairly quickly.
Yeah.
Again, competing against themselves, how many times can they hit the target, so to speak.
Yeah.
And then we'll ask them to do a quick summary here locally, share, kind of a showcase what they've learned throughout the week, which will invite the JSC community to come and participate in as well.
Oh, really?
Like we do with a lot of these activities, yeah.
Cool. So real scientists and engineers from here at the center come and check it out.
They'll have that open invite.
All right, cool. So they have a lot of time to kind of refine everything and practice, because they come here on a Monday, and by
Friday they're done and headed home. Bring that showcase. So they, really they get to spend about, out of that, 2 to 3 hours on the floor. So
wow,
it between all the teams, I mean, it's a lot of time, but an individual team gets about 2 hours on the floor is all.
Oh,
so.
That's right, because you got to share. I didn't even think about that.
Got to share. Yeah, got to share.
You got to share the floor. Okay. Wow, that's such a cool experience. Yeah, I had no idea that was something, because when I'm in high school, I remember dabbling in all kinds of different fields, right? Because high school is kind of the time where you try to figure that out, right? Okay, what am I going to do for the rest of my life? So you kind of do some challenges over here, some things. Do you find that the students are more sort of set on, science and engineering is for me? Or do you find them kind of, this is another step on their exploratory mission of what they want to do for the rest of their lives?
Being the first time we'll have students here, My guess is that we will find most of the ones that are coming here are really interested in science and engineering.
Yeah.
But I'm sure that there are a lot that are on the team back home that are still checking things out.
Yeah.
And I'm also saying that from my experience. I'm a former classroom teacher, taught physics, and was a robotics coach.
All right.
So there's so many facets to this program as well. We'll give them a chance to design their own team patch, or like a mission patch and such, that you can really bring in a lot of different things. Matter of fact, I was one of our teachers last year was actually the French teacher that was involved, but she was also interested in science and engineering, and she found ways though to work this into her French curriculum and all sorts of things. When you get creative, there's lots of connections you can make because everything is connected. But for the students, it'll be interesting to see this year because we will survey them before and afterwards if this changes their feeling about STEM careers or be it science or engineering or technology or whatever it might be. We will ask that question, so we'll have some better data later.
Definitely. No, it's kind of the mission of why we do NASA, education here at NASA is to kind of, is that fair to say? Is that, this kind of helps inspire the next generation?
That is exactly what we're trying to do. I mean, that's what these are all about. Not only inspire those students, but give the teachers that are working with them the tools to help not only the students they bring this time, but students in the future.
Yeah.
They may get a chance to do this, or they can go do something similar on their own.
Yeah. So that's, maybe lesson plans are a part of this, right? Or is that another part of NASA education? There are lesson plans.
It really is. We don't necessarily design a lot of lesson plans here per se. We do provide a lot of curriculum material. We talked about microgravity earlier and learning about that.
Yeah.
We have an entire lesson guide on microgravity demonstrations and lessons that they can use, which we'll be sharing with the educators, of course.
Cool.
But what we're really trying to do is get them engaged in these unique experiences and really give them that opportunity for them and their students to experience it and work that into their long-term development as an educator.
Yeah. Okay. Right. Because you got educators here, right? The French teacher,
That's
and
right.
You got other folks coming that are going to apply this, right?
That's right.
That's very cool.
And that's one of the things we found last year is that they found so many ways to do. This is something in education that's called project-based learning, and a lot of them are not. They may do this on a small scale, but they found this as a way that they can do more larger problem-based lessons back home. It gave them the courage to go home and do that, the knowledge to do it. It was quite a deal. One story I want to share that I thought was just so motivating to me as well, that it's important we do these, is we had a teacher here doing a great job, having fun. It was obvious, but was, from my point of view, was actually shocked at the end of the week as he's giving us a breakdown of what he'd learned. Is almost, I can't quote him exactly, but basically what he was saying was he had such a tremendous experience here and learned so much more about what he could share with students that he had decided not to retire and continue to teach.
Wow. How about that?
Yeah, it is very inspiring what they're able to do here and what they're able to take back and share.
A new wave of inspiration.
Exactly.
That's pretty cool.
So it's not just the young kids we're inspiring. It's those dedicated educators out there as well.
Yeah, decided to stick around. That's awesome. Not even retire. That's really cool. I could totally agree with the project-based learning too, because I'm thinking while you were talking about that, I was thinking about experiences in high school and earlier than that even, where I think the lessons, when it comes to like actual lessons that I learned and things I learned in school, the things I take away the most are whenever there was something very specific that I had to do. It was a task, right? That you had to start and then finish. And through that whole thing, you sort of can pull back and learn that broader piece of information, the whole purpose of why you were doing that project.
Right. That's what it's all about. We all know it works best, but sometimes putting it in action is not the easiest thing to do.
Yeah.
So this gives educators a chance to learn how to do it and gives students a large immersion into this kind of activity.
Definitely. Well, what about you, Mike? Because you're here as are you considered a NASA educator? Is that what you are, or do you have a different job title?
That's basically my job title, and
Yeah.
NASA Education Specialist.
Education specialist, yeah.
Do a lot of different things, design, this experience that we're getting ready to put together, which will involve so many different things, coordinate all that. So I'm kind of a program manager in a way,
Yeah.
but have to bring the education value to it, which is I think why, as a former classroom educator, it's excuse me, that's a requirement for my job. So.
Yeah. How did that career path go? How'd you get from high school educator to the physics teacher all the way to NASA? How'd that go?
Well, actually, as I was trained as an educator in college, but went off in another direction for the nonprofit for a while. But I was coming back into education. I knew that I needed to refine my science skills again. Anything gets a little rusty when you don't use it. So I was looking for some summer opportunities to, I didn't want to just go back to school, but I knew if I looked, I could probably find some opportunities. And fortunately, actually, Johnson Space Center, there were some opportunities to come down and be a mentor for, actually, that probably spend a week here at Johnson Space Center and work with students and find out all, and that's when I found out all the neat things that were going on here.
Yeah.
And did that, got me hooked on NASA again, because I remember the moon landing, so it's always been there in the back of my mind. But what could it do for education?
Right.
Excuse me. And once I found out there were opportunities, I started looking for more, and I found them. I had opportunities to go and do different things. And finally, I found out, hey, there's a job I can actually go do this. I applied, and a couple years later, I was lucky enough, and here I am. It was a journey itself.
Yeah.
So, but I'm glad I'm here. It is very inspiring to get to work with all these educators and students out there.
Definitely. Yeah, I was a student myself when I first got here, and transitioned more towards the mentor role, and so I can appreciate all this stuff that you're doing because I lived it. I was there. I was definitely inspired to come work here through the internships and fellowships and all the other opportunities too. I worked with I did a rotation in education, actually, working on various programs there. I actually did reduced gravity. That was one of the programs I worked with.
Okay.
Haas was another one. So what do you work with Haas at all?
I really work with them just a little bit, usually helping them during the summer when they have some students here when they need extra escorts for some of their tours and all. But as I mentioned, that program that I first had the summer to come and work for a week, that was the first year that they did Haas.
Really?
It was, and I was a mentor for one of those weeks during that initial year for high school aerospace scholars. So, yeah, I've worked with them off and on throughout the years as well.
All right. So, has it changed? Have you noticed since its inception?
It has. A lot of it is the same. They've refined. Really, what's to me the difference is then it was a chance to students just came and spent the week here and had a great experience, but they've added a lot of pre-work that the students need to do, an online course actually in preparation for coming and being here, and that's made it a deeper experience for the students. So that's been a great addition to it.
Yeah. And just to pull back even further, just for the listener's sake, it's a high school aerospace scholar, right? That's Haas, and it's kind of like Microgravity University, where it's a challenge-based course, and you come here for a week and do the challenge, right?
That's right. It's a series of smaller challenges that they do, like it's designing and building a rocket, a small robot. So it's a bunch of small challenges that they do. I believe almost a daily kind of focus challenge that they do. Again, not working with it directly, I don't want to talk too much, but it definitely does have those elements like our large challenge for Magoo has, but just on a little smaller scale.
Yeah. Just from mentoring it, I know that they, at least for when I was mentoring it, they did like a Mars robotics challenge, and you had to design a rover and then do this competition where you kind of had this mat that was your Mars, right? Your Martian surface, and they had rocks and little shiny pieces of water, I guess, and you had to collect as much as you could, bring it back to your home base, and then however much you collected, then that's how you won, and that was the competition. It was pretty cool.
It is, and that sounds very similar to there's a version that's for community college students, and that's definitely what the community college aerospace scholars does, or what we refer to as NCOS.
NCOS.
Yeah.
Okay. Is that for Texas Community College, or is that
that one's nationwide?
Nationwide.
And
Very
actually,
cool.
they do that one at multiple NASA centers.
Wow. Education has quite a few programs going on, huh?
It sure does.
Yeah, that's quite a few. I know just under the Microgravity University, we talked about this competition here, but then also we kind of skimmed it over, but Micro G Next is another one, right? That's
Right. Micro G Next is another one. That one's again focused at graduate or undergraduate college level students.
Oh, okay.
And it is focused on they work with the engineering team that works on spacewalking tools.
All right.
So they're given a challenge or two. They choose which one that they want, but usually there's two options that go out in the proposal. They choose which one they want to work on. They develop that, and then they get a chance to bring it here, and they work up a test that's actually performed in the neutral buoyancy lab.
Mm-hmm.
Students don't get to go actually dive and put it in, they work with the divers out there.
Darn.
Again, one of those little shucks, can't quite do that, but they're there, they're watching it right on the monitors, they're getting feedback from the divers about how well it worked, how easily, what the ease with which they were able to utilize the tool.
Yeah.
So they get all that same engineering feedback, very similar to what the engineers here do.
Yeah. Wow. Okay, cool. So, a lot of these challenges are kind of based off of literally what is done here at NASA.
Oh, definitely. It really needs to be tied into what we're doing, either running parallel, like we mentioned. What we're doing is very similar to launching the CubeSats on the ISS, and it's very similar to, a mission, working with mission control. But as you get into the Micro G Next, some of the others, it is very much what they're, what they can be designing as a tool, that maybe that design works its way into a real tool.
Oh, wow. Have you seen examples of that? Have you seen examples of student-run projects that got fit into like real?
Actually, there's several, and let me throw in another program. Throw it out there.
Yeah.
It's called Hunch.
Okay.
I cannot remember exactly what that acronym stands for, but it's basically high school students designing space hardware.
Okay.
And a number of different things. They've actually done some different challenges. One, space hardware. They've also done a food challenge where they actually come up with a new recipe, working with the food lab on that.
Sweet.
One thing they're testing right now on board the space station is footwear.
Oh.
To I'm not sure what you would call it, a slip-on booty, a moccasin, space moccasin, whatever it might be.
Space moccasins.
Yeah,
cool.
there we go. Because you got to protect your feet up there, but what I understand the problem is they when they lock in on some of the handholds or footholds.
Yeah.
We're not used to having tops of our feet in that situation, rubbing some sore spots. So they've developed these space moccasins. We'll go ahead and use that term, and they're testing those right now on board to see how well they work, and they'll get feedback from the guys and gals on orbit, and see how well they work, or make modifications and try it again.
That is so true, because they do a ton of science all the time. They're working all the time. 250 experiments going on in any 6-month increment.
Right.
There's just so much work to be done, including maintenance and all that. But you don't think about you're not walking. You're working with your hands, and your feet are locked into these handrails all the time, constantly jamming into these metal handrails. Of course, they're gonna get sore.
Right.
That makes so much sense. Wow. All right. Can't wait to see what these space moccasins are going to be on.
Yeah, let's see what I know they've worked on the dining tables and a number of other. Didn't brush up on that, but that's a great project as well. Again,
Cool.
It's called Hunch.
Yeah. All right. Yeah. The day-to-day stuff. That sounds pretty
That's
cool
right.
to work on that. All right.
There's one thing you mentioned earlier, if I can throw out there. You talked
sure.
about when you were an intern and others, how you were mentored through that program. And that's one of the things that we get with the microgravity teams that'll be invited to come down here during their design and building. And actually, while they're testing here, we're recruiting NASA, JSC personnel to be mentors, to work with them throughout that process, to be a technical advisor, coach, mentor throughout this as well. Of course, when they're designing, they'll be visiting with them virtually, email or whatever they are doing there. But when they're actually on site throughout that week, especially during testing, they'll invite their mentors to be there with them and go through that. And the mentors have a lot of fun with that as well.
I can imagine, especially, I mean, you're working through these challenges together. Just any kind of challenge-based thing. I could see anyone getting charged about that kind of stuff. That's really cool.
They are, they volunteer for it. We ask for volunteers. We're in that process right now.
Yeah.
So here's a shout out to anybody who wants to volunteer for that. But that's just another layer of the experience to have that NASA connection, with a mentor as well.
Yeah. Hey, that's pretty cool. You're coming to NASA, you're seeing all the cool stuff, doing real NASA challenges that are perfectly applicable to real spaceflight, and talking with NASA scientists and engineers along the way.
Right. And doing it in real NASA facilities. All at the same time. I mean, what else could we add to this?
All right. Well, Microgravity University, this is the place to go if you really want the true NASA experience. So I want to kind of end with just the overarching idea of education at NASA. Just talking about all of this, it seems pretty apparent, but if you can kind of put like a little, I guess because of the Christmas spirit coming up, a little star on top of this tree, or a little cherry on the fruitcake. Nobody likes fruitcake. What is the whole idea of NASA education? The purpose of why we do it?
Well, the purpose is to inspire and engage. If we're going to continue with exploration of the universe, it's going to take an educated workforce with lots of creative ideas and an understanding of what it takes to work out there, because it's not easy. It's not like being here. It's a different environment. It's lots of different challenges that we're learning more and more every day. We may, think we've solved one, but when we do, we discover there's 20 more that we have to deal with, wherever we're going, be it to lunar orbit or to Mars or beyond, whatever it will be. We've got to have people to do that are interested in this. So that's our job, is to inspire and engage and get those folks in the pipeline so that they can be involved down the road.
All right. That was a perfect way of wrapping it up, Mike.
I hope so.
Very cool. All right. Well, stick around till after the music here, and we'll recap that website for you of where you can apply to sign up and send your proposals to Mike here for Microgravity University and all the other cool stuff. There's more than just Microgravity University, so we'll kind of share that too. But Mike, thanks so much for coming on and describing all these cool challenges and the great experience that the students and educators are going to come do.
My pleasure. Looking forward to it.
Very cool.
Houston, go ahead.
Stop of the space shuttle.
Roger, 0G, and I feel
The
fine.
shuttle has cleared the tower.
indeed for all mankind.
It's actually a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Houston, welcome to space.
Hey, thanks for sticking around. So, as promised, here is the magic link where you can submit all of your good ideas, your proposals, to participate in the Microgravity University next year, as Mike said, in March. If you go to go.nasa.gov/NASAMAGOO, and that's NASAMGUE, Microgravity University. So that's where you can go and submit the proposal and find out everything there is to know about the program. If you want to know, and by the way, that's December 13th. December 13th is the deadline to submit those proposals. If you want to know all the other education programs going on, and sometimes, they're kind of scattered, so you got them going on all throughout the year. Some of them are in March, like the Microgravity University. I don't know, Haas and High School Aerospace Scholars is in more of the summer, but they kind of got spread out. But if you want to know all of the education programs, and maybe you're going to miss the deadline here, but you want to participate in the next upcoming one, go to nasa.gov/education. You can get a pretty good list of all the ones here at the Johnson Space Center, but then also all across the space agency at different centers across the U.S. If you want to know some of the things going on and see some pictures, if you kind of, didn't really understand kind of the visuals, Mike did a pretty good job of actually describing the visuals of how everything was set up. But if you want to see some of the programs here, just go to, it's on social media, at JSC Education on Facebook is where you can find all the stuff going on here at the Johnson Space Center. At NASA EDU on Twitter is where you can find all the education programs going on across the agency. And then also we like to share things on the Johnson Space Center accounts. So like we say in previous episodes, NASA Johnson Space Center on Facebook, and then at NASA Johnson on Instagram and Twitter, it's there too. So if you want to have a question about the show, just use the hashtag AskNASA, or if you have a question about how to apply or any of the education programs, use hashtag AskNASA on any one of those platforms and go ahead and ask a question. And if you have an idea for this show, just make sure to mention it for Houston We Have a Podcast. This podcast was recorded on November 20th, 2017. Thanks to Alex Perryman, Danae Fullwood, and Stacy Welch. Thanks again to Mr. Mike McGlone for coming on the show. We'll be back next week. Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, episode 22, Astronaut Health. I'm Gary Jordan, and I'll be your host today. So on this podcast, we bring in the experts, NASA scientists, engineers, astronauts, all the coolest people. We bring them right here on the show to tell you about more everything NASA. So today, we're talking about astronaut health with Natasha Cho. She's a flight surgeon here at the NASA Johnson Space Center in Houston, Texas, and she gave a great description about what a flight surgeon does and how they work with astronauts to monitor their health during spaceflight. So thanks to future Dr. Spaceman for the suggestion on Twitter for an episode with a flight surgeon. If you have suggestions for the topic you'd like to hear on the show, let us know. You can find where to submit everything at the end of every episode. No, I'm not going to reveal it right up front. You gotta listen to the whole thing. Plus, this is a really good conversation anyway. You're gonna really enjoy it. So, with no further delay, let's go light speed and jump right ahead to our talk with Dr. Natasha Cho. Enjoy.
T-minus 5 seconds and counting. Mark. All launch commit lights are correct. There she goes.
Houston, we have a podcast.
Oh, God.
No, we'll start with something happy.
Okay,
Natasha,
cool.
Thanks so much for coming on the show. Ran into your profile as part of Peggy's NASA Village project. You're one of the many people that supported Peggy Whitson, right, during her flight. So what was it like working with the Space Ninja?
So I think as anyone who works with Peggy will tell you, she is awesome at what she does. And she's just a joy to watch. Plus she's a wonderful person, which just makes it even better. So
Oh, yeah.
It's great.
Yeah, definitely. Just in the few interactions I've had with her where, interviews or her dealing with media, just, sitting down in a chair with a lot of people looking at her, lights, cameras, and she's just laughing, having a good time. It's just, you really appreciate that when you're on the behind the scenes stuff and the pressure that goes into it. But you were, for supporting her, you're a flight surgeon, right?
So I wasn't assigned to her as her crew surgeon, but I was, after her landing, her and Two Fish, I was the physician on the NASA aircraft that brought them back to Houston.
Oh, okay. Yeah. So you were out in Kazakhstan then?
So actually, this landing happened right after Harvey, and because of the multiple personnel impacts that NASA had, including to our aircraft operations division, we weren't able to get our aircraft staged in Kazakhstan in time for their landing. So what happened was we got the help from the European Space Agency. So they had an aircraft, and they went and got our crew in Kazakhstan, brought them back to Cologne, Germany, ESA headquarters, and then we went to Cologne to pick up our crew there.
Okay.
So that was like a total modified, unexpected,
very
direct
different
return operation. Yeah.
So you went from Houston to Germany then? Yeah. Okay. And so what is that? What's a doctor on call? That's what you said, right?
We call it the air dock.
Air dock.
Yeah.
Okay, cool.
So NASA has an aircraft that we use to bring back our crew from landing within 24 hours, and the purpose of that is just so the science and research folks can get data as soon as possible once the crew return, just because there's a lot of physiologic changes that happen not only right after landing but in the hours and days that follow.
Okay. Yeah, and you have to just kind of, so what's your job? Your job is to monitor it, to record it, to help it?
We do take some samples and stuff in flight on return, but the crew can be pretty symptomatic in terms of like returning to a 1G environment, and so we kind of mitigate a lot of the symptoms that they're having, motion sickness, that type of thing, in the early hours post-landing.
So now you're a flight surgeon now, right? Who's your crew member that you're working with?
So currently I'm assigned to Jeanette Epps, and she's launching next spring.
Okay. So what's some of the stuff you have to do this early ahead of time?
So right now, we just did her L-6 months physical, make sure that, she's still within standards for long-duration spaceflight.
Mm-hmm.
She's actually out of the country right now because in this part of the pre-launch time frame, she and Alex Kurst, her ESA crew member, and then Sergei Prokopyev, their Russian crew member, they're all serving as the backup crew to the prime crew that's launching this December.
Oh, okay.
Yeah.
So they're out there with Scott Tingle and
Yep.
Kanai and those guys. Okay, cool. Very cool. So you don't have to follow them for that then. You get to stay here.
Yeah. In the meantime, there's a lot of just like pre-travel prep, making sure all of us, including the docs, are up on our immunizations for, upcoming travel. In the next few months before launch, we'll also get together with her and our pharmacy and make sure that she's got any prescription meds she takes on a regular basis, put in these ISS medical accessory packs, or if people take, nutritional supplements or daily vitamins or whatever, like we make sure that all that is packed for them and any motion sickness meds they might need on the way up.
Okay. So how long have you been in the flight surgeon role?
So I got hired on full-time here a little over 2.5 years ago.
Okay, cool. All right. So let's back up just a little bit from all this and talk about what is a flight surgeon, right? Let's do that.
Yeah, so I gotta tell you, it is the coolest yet most misleading job title there is, because we don't fly in space, and the vast majority of us aren't actual surgeons. What a flight surgeon is a medical doctor who takes care of pilots and astronauts.
Okay.
But the job title is a total misnomer. It's kind of like, I think of it like the Surgeon General of the United States, right? So most of them these days aren't actual surgeons. So for those who are listening who aren't military buffs, basically dating back to like early wars, actual surgeons were the predominant type of medical doctor on the battlefield, and then that term has stuck in the military and NASA. And the flight part of the job title indicates that we take care of pilots and astronauts, but it also implies that we have at least some flying experience ourselves, either as private pilots, student pilots, or riding in the backseat of the T-38, the NASA training jet, along with our crew members. So that flight experience is actually key to understanding the physiology of the flight environment that our patients experience, as well as the psychology and the human factors aspect of like how they interface with engineering design and aircraft controls, and all that's especially important for maintaining crew safety.
How about that? So what are some of the main differences then? Like what separates, what makes you have that flight thing? What are some of the considerations whenever, I guess, the human body is in flight?
Right, so in flight, depending on the different types of maneuvers you're going to be doing, like if you've been to an air show, aerobatic pilots can do,
crazy
a lot
stuff.
of high G maneuvers, and depending on the order in which they do them, it can change, blood rushing to your head versus blood rushing to your feet. And if you do that in a very provocative way, you run the risk of what pilots refer to as graying out or blacking out and losing consciousness momentarily. So you never want those types of incapacitating events to happen in flight.
Definitely
and that's
not.
what we try and prevent. Another big thing that we learn about is hypoxia, right? So lack of oxygen. And so if your cabin, for whatever reason, depressurizes and you are, at the equivalent of tens of hundreds of feet, above sea level, that's going to feel a lot different than a cabin that's pressurized to a more normal environment. So our regular aircraft that all of us fly commercially, like a Southwest aircraft, for example, is pressurized to 8,000 feet. And most of us can tolerate that. But if you have a depressurization and all of a sudden you're at the equivalent of 30,000 feet, obviously your time of useful consciousness, or the amount of time it's going to take before you pass out because there's not enough oxygen up there at that altitude, is goes down to seconds. So those are the types of things that we have to learn about, and then we train along with crew to understand what our particular symptoms are in that situation, because it can be a little bit different for different people. Some people get a little bit loopy, some people have spotty vision, some people get shaky. It really depends.
Oh yeah, there's is a hypobaric chamber? What's
hypobaric.
Hypobaric, where they'll do that, right?
Exactly.
You'll go in there, they'll bring down the pressure, and they'll just like watch you and then write down some stuff. I actually had a friend that did that. She works in the MPL, and hers was actually, she said nothing happened to her. And I was like, oh, that's cool. And she's like, no.
It's actually bad.
Yeah, exactly. And it's because, right, figure out your symptoms.
Right,
So,
and if you don't have any symptoms, you could pass out like that, and we never want that to happen when you're at the controls of an aircraft, or
Yes.
if you're on an EVA and that happens for whatever reason. So
Okay. So do you understand, when you're a flight surgeon, you understand what happens for the crew members that you're taking care of?
right, and another thing that they do in training is a CO2 exposure class. So carbon dioxide is different on station than it is on Earth, right? The levels are different because here on Earth, if a room gets stuffy, we can just open the window. Can't really do that on station. So crew are exposed to about 8 minutes of carbon dioxide. It's basically they're breathing into a bag and they're rebreathing their own expired air during these 8 minutes. And they write down their symptoms for that as well. And that's really important because if levels tend to creep up on station, they have an idea from this exposure class, what their symptoms are and whether it's potentially attributable to the CO2 levels on station.
Wow. There's a lot of tests for being a flight surgeon where they just put you through the ringer. All right, well, we're going to deprive you of a pressure and see what happens. All right, keep breathing your own CO2, see what happens. What other kinds of tests are there like that?
Well, I've definitely done the hypobaric chamber, hypoxia demonstration more times than I can count now. So I think I've lost enough brain cells at this point. But, a lot of it, too, is written tests and stuff as you're going through, medical specialty training. So.
Okay.
Yeah.
Because I know, they do egress training for, I've seen the ones for Orion, I think, where they actually jump in, and I don't know if there's some health considerations there for where a flight surgeon would be for that test.
There are. So, Orion's supposed to splash down in the water,
Yeah.
and after you've been in space for a long time, that rocking motion in the spacecraft can be really provocative when you're already motion sick, and so, there's certain parameters as to how much rocking we would like versus not, and what all that is going to look like. So people are way smarter than me are working on that.
So when you're assigned a crew member, at what point do you start working with them, and at what point do you kind of say you're done and you kind of can go on to the next crew member or something?
So we usually get assigned to them about a year in advance or so.
Okay. Of their launch?
Of their launch. Yeah. It can be as soon as as early as 18 months pre-launch.
Oh.
And so it definitely ramps up exponentially the closer you get to launch. Like I mentioned, if you're in Star City as the physician, then you're supporting them through some of the Russian medical training that they do there. When they're here doing training in the NBL, you're at the NBL during their suited run. We also support their vacuum chamber runs in Building 7, which is where they test their EVA suit and make sure that it functions at vacuum. Mm-hmm. And then on the medical side, there's actually a lot of medical training that the crew get because there's no requirement right now that there's a physician on station. Mm-hmm. But each expedition is assigned 2 CMOs or chief medical officers, and those are USOS crew members who have a little bit of additional medical training, and so that could include putting in stitches or temporary dental fillings if needed, those types of things. Mm-hmm. And so we work with really talented nurses who help train our crew on how to draw their own blood, how to start IVs, all that type of thing.
Oh, okay.
Yeah.
And a lot of them are doing studies like that just normally, right? Like
some
blood
of it is
draws
research-based, yeah.
Some research-based stuff, I guess, besides the medical side. But
right.
Okay. So then you, if there's no physician on the station, mm-hmm. the backup is to have a physician on the ground, right? That's the normal way of doing things. And flight surgeons sit in mission control. Mm-hmm. So is that part of, how often are you doing that?
So when you're assigned to a mission, you're on console a few times out of the week, and that's only because you rotate with other crew surgeons who are working that same expedition. Oh,
okay. So it's not just you; it's like a team.
No, it's like
folks.
A team of 4, right? So
right.
each Soyuz launch, on the NASA side at least, has 1 prime crew surgeon and 1 deputy crew surgeon who's their backup essentially, and then it's usually 2 Soyuz crews at a time, and so that's what makes up the 4 docs that kind of rotate sitting console.
There you go. Yeah. So what are you looking at when you're on console?
So on console on a regular day, we mostly focus on the station, what we call the bioenvironmentals. I like to call it the vital signs of station, right? So what's the CO2 level today? What's the pressure, in the modules that the crew's working in? What's the O2 level? what's the temperature, what's the humidity, and then we look at their timeline every day. So as you probably know, the schedule for each crew member is planned out to like 5-minute increments.
Oh yeah.
So there's always reviews of plans for, the current day, 1 day out, 3 days out, 7 days out. And so we're just verifying to make sure that, everyone's got 2 hours of exercise blocked off. That, on most days, unless there's an extenuating circumstance, everyone's eating lunch together, because that's really good for, crew psychology.
Yeah.
And then making sure that there's nothing, that's unnecessarily interrupting sort of their wind down period at the end of the day before they go to sleep. It's kind of like if you got called about something for work at like 9 o'clock at night.
Oh,
you know what I mean? So
no,
we try and like really minimize that kind of thing. And then overall, we also have to approve any overages to their kind of weekly duty hours to make sure that they're not, at risk of burning out for like working too long of a week. And so if that ever happens, we have weekly meetings with the flight director to make sure that that time is made up the following week if they get a day off or some time off subsequently.
So you must be really close with the astronauts then, because you're the one that actually protects them from working.
Yeah, so I mean, the role of the flight doc these days, back in World War I when flight docs first started, I feel like there was a little bit of animosity, right? Between flight docs and military flyers, because, the best that you could ever do is come out even from an appointment with your flight doc. The worst that you could come out is that they would ground you for some medical reason. But these days it's a lot more, we're definitely their advocate, right? And want to make sure that we create an environment that is conducive of them, flying happily and safely and healthily.
Yeah. I mean, what does a flight surgeon do to make sure that they are in a state of mind where they can perform hundreds of experiments and do all the tasks that are assigned to them on a daily basis?
So that's actually something that our behavioral health and performance group focuses on, and we work in consultation with them. But essentially, we've got crew psychologists and crew psychiatrists that are assigned to each crew member. And then, before their mission, they meet with them on a regular basis. And then during the mission, they have what they call PPCs, or private psychological conferences, every couple of weeks. And those docs also will be in touch with the crew member's family, especially after events like Harvey, right? Something totally unplanned, and that can be a huge stressor for folks on orbit and their family members on the ground.
Oh yeah.
Yeah. So they're very good about, before astronauts are even selected, like screening for people who are psychologically, very stable. Once they're selected, making sure that they have all the resources they have pre-mission, during mission. They talk about, if there's bad news, how do you want it to be delivered? Who do you want to deliver the news? How do you want them to deliver it? So that group is really, I think, paramount to crew well-being, and then keeping the family members in the loop as well. Regular communication.
So that's not flight surgeon job then?
No, it's more,
totally
it's BHP.
BHP. Yeah, exactly. What qualifies an astronaut as being able to go to space medically healthy?
So what we look for is overall medical fitness for the stressors of spaceflight. And that begins, like I mentioned, with, selection criteria during the application process. So once they're selected, if they have an illness or an injury, we get them treatment and the specialty care that they need. And then we have an air medical board that actually reviews their case files on a regular basis to recertify them for flight if they happen to be grounded for whatever reason. It's actually similar to how the military and the FAA medically certify their pilots. And as a taxpayer, for those of you listening out there, so these processes are also in existence to help keep the general public safe. So in general, the FAA has a role to keep the risk of a pilot having an incapacitating medical event to less than 1%.
All right.
So we kind of follow very similar standards. But in order for crew to stay healthy, essentially, they have to train, right? So, so like I mentioned, we work with really talented physical trainers, psychiatrists, psychologists, pharmacists, nurses, to make sure that our crew are not only physically and mentally ready for long-duration spaceflight, but they're also capable to administer medical care to each other if necessary.
Okay. Are you overseeing their their workouts and stuff like that, or is that a totally different thing?
So that's the job of our ACERs. So those are astronaut strength, conditioning, and rehab specialists. It's their personal trainers, essentially.
Okay.
So when crew go to orbit, they are actually given what we call an exercise prescription.
Huh.
And they've got different goals that they can work towards and modify if needed in space. And all of that essentially is part of it's actually, I think, one of our most successful countermeasures, right, is maintaining your bone and muscle mass. So we know that maintaining your muscle mass with resistive exercises and getting some sort of impact exercise like on the treadmill is really helpful in preventing bone loss and muscle weakness post-flight.
Yeah, definitely. What about, you said there was a pharmaceutical component to there. Are they making sure that they get doses of certain medicines to stay healthy? Like, I don't know if they do calcium supplements or something like that.
So we actually, we have a great pharmacy here at JSC.
Okay.
And pharmacy helps pack any, regular prescription meds that people fly with.
Mm-hmm.
And in addition, they can let us know. There's been some research, hasn't been enough, but, certain meds just don't do well in space for reasons that we still don't completely understand. So some medications, if they're in liquid form, will bubble or foam too much to be of any use in space. It's harder to draw them up in a syringe because you don't have that same air fluid separation that you do with gravity. So we can't fly those meds because it wouldn't be useful.
Right. But they're probably meds that you would need, right? So is there a workaround?
So there are alternative meds that we can fly instead.
I see.
In the meantime. And then we also have medical kits on station with Tylenol and ibuprofen and things like that if people happen to need those during their mission.
So that's kind of the essential, like, if you're going to fly, this is probably what you're going to need. You know, like the stuff like that, just in case some small thing were to come up. Oh, we got a slight headache. Boom.
Right.
Good to go.
Exactly.
Okay. Cool. What else besides Tylenol? I guess that they would need.
There's antibiotics on board if there's any sort of infection. But it's also kind of like what you have in your kitchen cabinet, or in your bathroom cabinet. So Pepto. Those types of things.
Okay. Yeah. Cool.
But the quarantine process is actually pretty interesting.
Oh,
so
yeah.
I haven't been through that yet myself. I'm the prime doc for Jeanette, so I'll be in quarantine with her. But essentially, we go from Star City, Russia, where they train with the Russians, and the entire crew then flies down to Baikonur, Kazakhstan together.
Okay.
And then the prime crew and their prime docs will be in quarantine in Kazakhstan for about 2 weeks leading up to launch. And so every day, we take temperatures and do a quick physical exam. And there's a Russian epidemiologist down there who's really strict about, who he lets in to visit the crew and stuff. So no kids under 12, that type of thing. And anyone who does want to visit the crew has to, have, written evidence of 3 days of no fevers and
wow.
So, yeah.
All right. It is strict for that reason, right? They don't want to bring anything up there. So what's the have you been in the quarantine environment as a flight surgeon?
No, this will be, I've visited it, but I haven't stayed there.
Oh.
Yeah.
So for Jeanette's launch, that'll be the first time you're gonna do it. Okay.
Yeah, so I've toured it. There's like a gym, there's a place where they eat meals together, and they have folks who are in quarantine with them, like cooks who stay there and cook for them as well. So
who have also gotten the check mark.
Exactly.
They can stay there.
Yeah.
So it's like a little place for them to live for how long before?
About 2 weeks.
2 weeks?
Yeah.
Oh, wow. Okay, that's longer than I thought.
Yeah.
Yeah, because, you don't want anything to develop. How about that?
Right. And then, obviously, flu vaccinations, depending on what time of year you're launching, are important for everyone going downrange to have as well.
Absolutely. All right, so then they're quarantined, and then they go up to the International Space Station. You said they have very limited training when it comes to they could do small things.
Mm-hmm.
But what sorts of things do you prepare for and prepare your crew members for an emergency?
So actually they go through what we call mega code training. And so this would be worst case scenario, right? Like if someone needs CPR. We work again with our nurse trainers. Typically they're nurses with ER backgrounds, and then the flight surgeon as well is watching the crew kind of go through this training after they've had a few sessions of hands-on, training with us prior. So, and this is done in the ISS mock-up actually, and so we have an AED on station if needed, and so they run through a very modified but basic algorithm that they would go through in that situation.
All right. So Okay. And you'll, in this situation, are you on console helping them out?
Yes. So we would, we always have a crew surgeon on console during normal working hours, and then we're on call the rest of the time when we're assigned to that mission.
Oh.
So if we're not sitting console on a regular shift, we would get called in for that.
All right, so no vacations. You gotta stick around in case someone gets pulled in. But that's good, right? Because then, the crew members flying know that, all right, in case of an emergency, I know my flight surgeon is going to be there. So whenever you're designing, procedures, I guess, do you practice knowing about microgravity? Like, okay, the AED is we're gonna have to do it this way because, you can't just lay someone down, maybe strap them down or something like that.
Right. So we actually have a crew medical restraint system on station.
Okay.
And so the crew know, to put an incapacitated crew member there so that, they don't float away. It's a lot different than it would be on Earth. And so, yes, all our procedures are written to account for the microgravity environment.
Okay, cool. Yeah. Is there any concerns from the flight surgeon area? Some unique things that flight surgeons at NASA have to deal with that maybe other flight surgeons in the military don't have to worry about because of the microgravity environment?
So the biggest thing I'd say, like you mentioned, is medications, especially like liquids that don't separate from air. And so we're still trying to figure out, how to work around that for meds that we do want to fly but currently can't.
Okay.
Yeah.
So it's really just the limitations.
And so there are industry filters and stuff that the neonatal ICUs and that type of thing have worked with, and those could potentially be helpful.
Cool. So flight surgeons, I'm trying to think about like your total duties, and they seem pretty widespread, right? Like, so you're working with the crew before they launch, when they launch, in mission control. You even talked about some travel, right? You were flying out to Germany. Have you been to Kazakhstan or Russia too?
Yeah, so I'm one of the contractor docs, and so part of my job is to be in Star City, Russia, where the crew train on Soyuz systems. Okay. And so I'm there 2 to 3 months out of the year. And that's actually really fun. I kind of like that. It's a very family environment, and cool. The crew get together at night, and we have family dinners and things like that.
Oh wow! Yeah. So it's nice and tight knit. Like family dinners where? Like, is where they're staying?
Yeah, where they're staying.
Okay.
Yep. And then so I've been to Russia for that, and then yes, I've been to Kazakhstan for a landing as the air doc again on the NASA aircraft.
Cool.
Yeah.
NASA aircraft. So that was that the G3?
It was a G3, now it's a G5.
G5. Yeah. Okay, so then that's the one they take from where to where? From
Kazakhstan to Houston, and that's the direct return, what we call direct return within 24 hours of Soyuz landing.
Ah, okay. Yep. So you're just watching the recently landed astronauts and kind of taking care of them? Yeah. Very cool. Did you take some of the helicopters out to the landing site?
I have not, actually. So I was on a Russian helicopter for Kate Rubin's launch. I was her deputy crew surgeon. And so for launch, the prime crew doc is near the launch site with the guests and family members, and then the backup doc, or the deputy doc, which was myself, is in a Russian search and rescue helicopter. In the event that there's any sort of launch abort scenario, we would be the ones to fly out to wherever the capsule would have aborted to.
Oh, okay. Yeah. First responders, boom, you're going.
Yep.
All right, but you actually you said you flew in a helicopter for Kate Rubin's landing?
So you stay on, they have the blade spinning, but you're staying on the tarmac.
Got it.
Until you get verification that they've reached orbit.
Okay.
Yeah.
Very cool. So what do you have to study? What do you have to do to be a flight surgeon? Like, what's your background?
Yeah, so my background is emergency medicine. And then to work at NASA as a flight surgeon, you need to do an additional residency, and that's medical leave for specialty training. And that residency has to be in aerospace medicine, not flight surgery. That's not a thing. So the expectation essentially is that you're a competent physician in whatever your chosen specialty is.
Okay.
Before you pursue aerospace medicine, because it's such a small and specialized field.
Yeah.
I get a lot of questions actually from med students asking what they should specialize in if they want to become a NASA flight surgeon. And I always say just choose what you love, because if you love it, you're going to do it better. And that's what people are going to notice, and that's when doors are going to open to you. Because we've had neurologists, urologists, OBGYNs become flight surgeons and work here. So it's all about what you enjoy doing.
Yeah, because they were really good at, and you said yours was emergency medicine?
Mm-hmm. Yeah.
So what was that, what were you doing before NASA then in emergency medicine?
I actually went straight from emergency medicine residency to the UTMB aerospace medicine training program.
Oh, okay.
Yeah, so I was just working, 60 to 80 hours a week.
Yeah, wow. All right.
In the hospital before doing the aerospace program.
All right.
Yeah.
So then, what was the aerospace program? How did you translate emergency medicine into an aerospace environment? Like, what was different?
How did I transition it? I guess the emergency part applies to aerospace medicine in the event of, like a mishap.
I see.
Right? So, or planning for a mishap, but not necessarily hoping that that's what happens, right? So it's all about preparing for the worst and hoping for the best. So emergency medicine, background-wise, can help you figure out what equipment you might need to pack or what equipment you can leave behind. What type of personnel and staffing and other resources you might need at different stages of like a rescue scenario.
Yeah, because I guess you would have to operate assuming that you might have to do something maybe on a site, so you're going to have to bring everything with you or something like that.
And you always have to think one step ahead, right? So like, let's say I do this first step and it works, but then something else, changes with the patient after that. Then what do I do? And so you have to kind of work out these mental algorithms as to every possible scenario.
Okay. And then from there, you kind of came into the world of NASA, I guess, through...
Yeah, so the UTMB Aerospace Medicine Program is actually joint with NASA. And so we do some of our rotations here when we are in training. And so one of the ones is rotating through the flight medicine clinic. And so you're doing some of the astronaut physicals at that time. And then you've got other projects operationally that are given to you by different preceptors and mentors. One of my favorite ones was actually doing a 1-month rotation with the BHP psychologists and psychiatrists. Just because it's not my specialty, and so I still find it like super interesting though to work with them and see the types of issues that they deal with, and then interface with the operational flight docs on.
All right, very cool. And now you're here at NASA. Now you're a flight surgeon. It seems like like I said before, your duties are widespread and you're all over the place. But what's like a day-to-day sort of in the life of a flight surgeon?
Yeah, so it's funny. People always ask me, they're like, "What's a typical day for you?" And I'm like, well, hey, I wouldn't say we have typical days. I would say we have typical weeks, but every day can be a little bit different. So we are in an engineering community, right? So we're the minority, and a lot of times we're looked to as medical consultants. And with Station being as complex of a program as it is, there are a lot of meetings with all these different disciplines to make sure that we're doing the right thing and maintaining the health and safety of the crew at the top. So a lot of times, I'll have a day that's nothing but meetings with, potentially questions for me about making, just verifying that like what we're doing isn't medically contraindicated or unsafe in any way. Another day I might have my crew member doing a suited run in the NBL, and so I'll be there observing that. And another day I might have a couple meetings in the morning, and then in the afternoon my crew member will have some medical training that I'll be attending and just making sure that if they have any questions that I'm there.
Okay. Yeah, it seems like your role is more operational, right? So if something's happening, like boom, you're there. So the neutral buoyancy laboratory, that's a good one, right? That one's where the astronauts actually get suited up and practice doing a spacewalk in the pool.
Exactly.
Right? So what's your role? Do you go behind the scenes and kind of check them out beforehand afterwards, or is it more you're just kind of standing by watching?
Yeah, so everyone who goes in the pool gets a dive physical beforehand.
Dive physical,
and
okay.
Then during the run, which is typically about 6 hours, I'll be on the loop just listening and making sure, if there's any medical concerns, they can always request a private loop with the NBL medical director. But as they're assigned flight surgeon, it's always good for us to be there as well, just so we're aware of any issues.
Yeah. See, privacy is pretty important when it comes to this stuff,
Absolutely.
Right? Absolutely. Yeah. So that your job is kind of like that, right? Wherever you do, you have to make sure that you are protecting the privacy of the astronauts' medical information. So how does that work, I guess, in an environment where everyone's talking to each other, especially in mission control?
Yeah, I guess it's not too different from the hospital environment. I think, there are people who interface with us, for example, a biomedical engineer who have essentially signed the equivalent of like, a HIPAA understanding of the HIPAA laws and medical privacy laws and Privacy Act.
Oh, because they're hearing some of this information too.
Right, and the ones who are involved in these types of conversations are involved because it's a need-to-know basis. And so that's essentially how we operate.
Okay, cool.
Yeah.
And you guys have private medical conferences with the astronauts too, right? Like every once in a while you're checking in. So that's, is it more of just that? It's just checking in, seeing how everything's going?
Yeah, so it's once a week, and it's for about 15 minutes, and it's a video conference, direct to station with a crew member on a private loop. And, you know, it's all documented, and the chart, the medical chart from that encounter will go into the electronic medical record. And so we can always look back and see if there's something that we've been tracking over time, you know, how it's been progressing. But it is mostly a check-in, but, you know, every once in a while something will pop up. We know that there are slight immune system changes in space, so people can get rashes or, you know, just feel stuffier, have allergy-type symptoms. And so a lot of times that's what we deal with.
Okay, so it's how much of it is, you know, I guess you're recording, just checking in, and then, you know, sometimes you're gonna have to deal with stuff like that, right?
Yeah.
So how do you deal with it when you're down here in Mission Control, but your patient is up in space?
Yeah, so that's the art of telemedicine, right? Is you can't see and touch and feel your patient yourself. And so we rely on their pre-flight medical training that we talked about. So they're taught to use, you know, how to use a stethoscope, how to take a blood pressure, how to measure heart rate, that type of thing. And then we have the magic of camera technology up there. So, you know, they can actually look in their crewmate's ear and take a picture of what that eardrum looks like and send it down to us. Or they can just take a picture of a rash that's developed and send that down to us. And then, you know, during the private medical conference, we can ask all the other questions. We want to know how long has it been there, and, you know, is it getting better or worse, and what makes it better or worse, those types of things.
Are there things that are normal for space flight? Like, are there particular, you know, microgravity rashes or something like that that's just typical for being in a space environment or something like that?
Rashes can develop, yeah. So that's probably not uncommon, and it's because airflow on station is different than on Earth, right? Like, particles have weight to them here, and there's constant airflow that moves things to different areas. So air doesn't, heavier molecules don't dissipate or, you know, sink the same way on station. If you're staying motionless, the air particles around you are just gonna heat up, and you kind of have this, like, cloak of warmth, right? Or for another example would be if you unpacked something and it had, you know, particles of dust. The dust isn't gonna, like, fall to the ground.
Oh, it's going right up.
Yeah. So eye complaints can be a common thing that we hear about after something like that. So we've got protective equipment up there. If we think something's gonna be particularly hazardous for them to open or unpack, we recommend that they wear goggles and that type of thing.
Wow.
Yeah.
I would not have thought a heat shield, I guess, that's happening because of the lack of circulation. That's
actually documented in Lost Moon, Jim Lovell's book about Apollo 13, when they had to turn a lot of the power systems off. It was really cold in there, but they found if they didn't move around as much, their body heat actually heated the air particles around them.
Whoa.
Yeah.
That is wild to think about. So that's what I was talking about when I was asking, like, what are some of the microgravity things that are just different? That's perfect. That's exactly what I was thinking. I would have never thought, like, so if you just stay still, you stay warm because you're kind of moving. It's just a different air environment.
Yeah.
How about that? So I guess, are you the one in charge? So if they are unpacking something, for example, like, you say, hey, you definitely have to wear goggles for this or something like that.
It actually depends on who owns the hardware. But there's a lot of other system interfaces that I'm not privy to that I think come into play, and the biomedical engineer helps us out with that as well. So they biomedical engineers essentially are what we call them the nuts and bolts. They work with the nuts and bolts of medical hardware, right? So if the ultrasound machine breaks, they troubleshoot that. If the human breaks for whatever reason, like, that's our job. We're the blood and guts.
Blood and guts.
Yeah, but the rashes, going back to the rashes, so the reason sometimes rashes develop is, so back to our example of unpacking something that's new, maybe it's off-gassing some sort of particles, and those particles, if they're not circulating in the air the same way that they do on Earth, can sort of linger in one space, maybe near your skin or something, and that sort of exposure with, I guess, not as efficient airflow as you would have on Earth may make the skin react a little bit. But there's also, like I mentioned, some immune changes that happen, and some rashes and allergy type symptoms can be related to that as well.
Oh, because your immune system isn't operating as much, so you react, I guess, a little bit more fragile.
Yeah, so that's something we don't totally understand yet. And even on Earth, the immunology is one of the least understood medical specialties out there. And things are always changing.
See, I don't understand why I get a flu shot sometimes, and then a month later I get the flu. I don't understand. I should be completely protected. And that I know there's like, it changes strands or something. So anyway, but a lot of different things to think about, I guess, from your end, especially. Just that's a totally different world. Are you measuring some of these things over time and then understanding trends? Like, are there certain trends that you've seen just from studying astronauts in space for so long?
So we've got a group of epidemiologists and then folks on the research side who are studying particular body systems, for example, like urine chemistry or whatnot. Those are the ones who are typically measuring those types of trends.
Okay.
Yeah.
So
anything that goes into our electronic medical record, we can have the epidemiologists look at, and they can, identify trends, and they can control for changes in like the CAT scan machine that was used from this mission to this mission, and control for age or gender or whatnot. And so it's a lot of number crunching and doing statistics and making sure that any trends or changes that we're seeing are statistically significant.
Okay.
Yeah.
Yeah. Because I know, like, just understanding just basic, when you go to space, this is something that happens sort of things, right? So your immune system gets a little bit weaker. Your muscles and bones start to, get a little bit weaker and disappear, so you have to build it back up and do this exercise all the time. Just medical things that you have to think about, the human body, how it reacts to space. And these are lessons that we can take to missions beyond low Earth orbit too, right? To station, our past station to, the moon, deep space, Mars, all of that stuff. So how is the role of a flight surgeon going to change as the communication starts to get a little bit, longer? Because when we go out to Mars, you're talking about when Earth and Mars are at their furthest point away from each other. That's like a 40-something minute round trip for communication.
Yeah. So, and the question is, right, like, do you then have a requirement to have a doctor on board? And not only that, but what if the doctor is the one who is sick and becomes the patient? Then what, right? Because when you fly in an aircraft, you've got a pilot and a co-pilot. Mm-hmm. But if you only got one doctor, I don't know, like, is it enough for someone else to, be trained as a mid-level provider, like a physician assistant or a nurse practitioner? Or is it enough to have just-in-time, like, on-orbit, refresher training videos for a non-physician to be able to do a medical procedure? Do we need, minimally invasive surgery type capabilities on these spacecraft? Those are all questions that, like I said, people way smarter than me are looking into, and challenges that we still need to address.
Wow. Yeah, there's a lot of different considerations. We just did a podcast pretty recently with Orion, and they were talking about just like, for example, oxygen or something, right? Like, oxygen is super important to have on the spacecraft, but you can only put so many oxygen generators on the spacecraft before it becomes a little bit, okay, let's calm down, because you have backups, but you can't just keep making backups until you're perfectly fine. So same with the physicians, right? You can't just have like an army of doctors going to space, because it's just, you need the other things, right? You can have a doctor, but then you need, if you're doing Mars exploration, maybe a geologist, maybe an engineer, maybe a pilot. You need all of the above. Nice, like, diverse group of astronauts who can do it all in one mission.
Yeah, and I think also the crew psychology is going to change a little bit. And so, people have talked about what's the ideal crew makeup. Should they all be all one gender? Should they have an even number versus an odd number? Because if you have an even number and you have a disagreement and you vote on something, what do you do if you have a tie? But if you have an odd number of crew members and there's one person who's the tiebreaker, are they then sort of, like, labeled as
choosing sides or the bad guy or something?
And then there's questions about what degree of assertiveness or leadership do you want in your commander versus someone who fosters more equality and community in a multi-month, like, transit phase from Earth to Mars, where there's not a lot going on. So do you really want somebody who's, like, super dominant on you all the time about something when there's not a lot of operational things happening.
Yeah.
So a lot of factors that are going to be in play, but I think crew psychology and wellness is going to be huge.
Oh, yeah. I would assume that whatever crew they choose to do these deep space missions, they're going to be, be able to do it all, in a sense. They'll be super qualified people that have multiple different disciplines. And even with the most recent astronaut class, that's reflected there, too. You got doctors with flight time. You got, Navy SEAL / doctor. You have, an engineer in 4 different disciplines. So it's, you got all of these people that can do it all. It's pretty cool. I guess from a flight surgeon perspective, you would probably vote more towards the redundancy in doctor ability, like a doctor and then someone trained mid-level with the doctor's position. Or do you have a different view?
Potentially. Okay. Yeah. I mean, I guess I haven't really thought about it too much. I was just kind of like throwing out ideas, but I mean, it's always good, to have backups and potentially backups to your backups.
Yeah. So how about whenever, we're going way out into space, but I'm gonna pull back for just a second. Like your first time going out over to overseas to support like a crew thing. I'm asking this selfishly because I'm about to go over to Kazakhstan myself. So what was that like, that experience of working with the crew before a launch or after a landing or your first time?
So it actually felt very natural to me, and I think part of the reason is because I was a Peace Corps volunteer like before I went to medical school, and I lived in that region of the world. So I was doing service in Turkmenistan, and so to be in Kazakhstan was almost like coming home. So I felt very comfortable, and part of that experience really turned me on to the International Space Station program because of the international cooperation part of it.
Yes.
So going over there was actually really fun for me. I really enjoyed it. And as to like the actual pre-launch experience, so as the deputy crew surgeon for my first mission, your job is to take care of the family and launch guests that are invited. And so, some folks aren't frequent international travelers, and Kazakhstan's fairly remote. So, if you've got medical conditions, I was trying to remind people to bring all the prescription meds that they're going to need, because we don't always necessarily have what they're going to need. We do carry a small medical pack with us with like some sleep meds and, allergy meds, that type of thing, in case it's needed. And then really it's just getting to know them, getting to make sure that your prime surgeon who's locked in quarantine has everything they need. If not, we can arrange to have extra supplies brought into them, medically if they need something. And then the day of launch, depending on what time you launch, this may happen earlier or later, but I got up super early you always have a nurse with you when you're going out into the field. And so we had the search and rescue forces pick us up in a van, and we went to the remote airport where their helicopter is staged to stay on the helicopter and wait for launch. And then once we got word that the crew had reached orbit, then the helicopter blade stopped spinning, and then we just go back to the hotel. So on an ideal day on launch, like, you're actually not doing too much because things are working as they should.
Right, because your job is to be there. Like, the helicopter blade spinning is the perfect analogy to, if something goes wrong, you're getting in the helicopter, right? That is your job. Otherwise, the blade stops spinning. Right. So that's exactly cool. Wow. All right. A lot of cool stuff to do as a flight surgeon. Is there anything I missed about flight surgery? Because a lot of this is very foreign to me because I, medical stuff goes like right over my head. But I try to do my best to kind of summarize everything into something that's, that we can tell out to the world and that makes a lot of sense and kind of encapsulates the story of astronaut health.
Oh, so there was one thing I was going to say. And this is kind of like a misconception that I think is important to clear up for folks out there who are interested in becoming a flight surgeon or who are in medical school.
Yeah.
So some flight surgeons have gone on to become astronauts and subsequently flown in space, but they're in the minority. So being a flight surgeon is not a shortcut to becoming an astronaut. I'm sorry if I'm crushing any dreams out there. But we get to do a lot of what an astronaut does, except fly in space. So we're with them for a lot of the training they do, and while space is no doubt the best part of being an astronaut, it's a pretty small percentage of their career, so like I don't feel too bad about my job. I actually love my job, and it's there's another doc in our group who refers to it as being like taking care of Lewis and Clark.
Oh.
And so I think that's totally appropriate, and it's super rewarding. We are one of the first faces they see, on landing. So if you see the PAO shots of the crew getting pulled out of the Soyuz, we're like the other person in the blue flight suit, like in the corner,
Yeah.
making sure that they're okay. Along with we've got great Russian field medical nurses that help us out with taking vitals and all of that. So
That's right. You're there for every step of the way, except on the International Space Station.
that is okay.
Yeah, that's true. Oh, really? You wouldn't want to fly?
Oh, no, I just mean, this job is so rewarding for me is that I'm happy as a clam.
Hey, yeah, you can't complain, because you're doing some really, really cool stuff. Yeah. That's really awesome. Yeah, well, if you do, want to be a flight surgeon / astronaut, is it Kjell Lindgren? Kjell Lindgren was a flight surgeon turned astronaut,
and
right?
Mike Barrett, Tom Marshburn, and then Serena Anand Chancellor next year.
What? Oh, all
they
of them
were all previously flight surgeons.
Oh, so you say it's low, but there's quite a few. And, definitely a medical doctor, I think, would be up there for someone who is essential on a deep space mission.
Agreed.
I definitely think, for missions beyond, they're gonna be up there, because the human body is like it's one of the things we're focusing on when we're doing studies on the International Space Station, right? Like studies on the human body, but then it's going to be a huge factor for missions beyond, because there's different things they have to worry about.
And we're the most annoying variable, I would say, right? Like to an engineer who's focused on, the spacecraft and like things being like within binary ranges, we have the most variables within our physiologic system to have the potential to drive folks crazy. So sometimes we'll get questions, like, well, what's, how low can this temperature be or whatever. We're like, well, it depends. It depends on, all these different factors. And so I know that's hard to hear sometimes. So, we have to bound the question appropriately, and then, start from a place that's, medically, ethically, safe for the crew. And then that's your starting point to work from there.
Yeah. Man, and it's got to be so cool just working with an astronaut throughout the whole thing. Have you ever done a zero gravity flight?
Yes. Yep. That's part of our training as well.
All right. So that's pretty close to space, right?
Yeah.
It's like you kind of feel the microgravity.
It's for about 30 seconds at a time. Yeah. It's pretty much exactly how I imagined it, like in my dreams as a kid. It was actually super fun, and it felt like Christmas.
Yeah.
It's like the best way I can describe it.
Wow. Did you were you there as flight surgeon, like with an astronaut, or were you there for something else?
I was there as like an aerospace medicine resident in training. It was sort of just like an exposure flight for me.
Yeah.
Yeah, it was fun. It was super fun.
All right. Something definitely cool to get exposed to, right? It's like a once-in-a-lifetime kind of thing. That's pretty cool.
I'll take that over the, losing brain cells in the hypoxia chamber.
Oh, yeah. Unfortunately, that's the thing you've done multiple times. Multiple zero-gravity flights would be pretty cool.
Yeah.
All right. Well, Natasha, thanks so much for coming on the show. I think this was a nice overview of what a flight surgeon does and how it helps in, every step of the way for Lewis and Clark. I love that analogy. That's perfect. So thanks for coming on the show and talking about what a flight surgeon does.
Thanks for having me.
Very cool.
Houston, go ahead.
Stop of the space shuttle.
Roger, 0G, and I feel
The
fine.
shuttle has cleared the tower.
Became indeed for all mankind.
It's actually a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Never Houston, welcome to space.
Hey, thanks for sticking around. So today we talked with Dr. Natasha Cho about her role as a flight surgeon and what that has to do with astronaut health. If you kind of know what's going on in the role of human research and how that applies to spaceflight, nasa.gov/HRP is a great resource for all of that. Everything human research and how that applies to spaceflight. If you go to nasa.gov/ISS, you can figure out all the stuff going on the International Space Station. A lot of that has to do with some of the human research we're doing, as we talked about in this episode. Otherwise, on social media, you can follow us, Facebook, Twitter, Instagram. Follow the International Space Station accounts. They're verified, and, we got a lot of followers, so you can find us pretty easily. But just use the hashtag AskNASA on any one of those platforms if you want to ask a question about the show. And actually, that's where I found the recommendation for this show is actually on Twitter. So I'm paying attention to all of that. Just make sure to mention it's for Houston. We have a podcast, and then we'll go from there. So the credits for today go to John Stoll and Alex Perryman. Thanks again to Dr. Natasha Cho for coming on the show this week. This podcast was recorded on November 15th. We'll be back next week.